Hello guys, this is the second session of February 25th. Okay, so I'll try to solve another um, another medium problem with high acceptance rate and reasonable frequency. I did this in the previous session, and here this one. Sort matrix diagonally. Yeah, let's solve this. Um, before solve this problem, let's start the timer from 60 minutes. Should. Okay. Time is clicking. Time is ticking. Okay, let's solve this one. It rains a lot, by the way, here. Sort matrix diagonally. Diagonally.
Diagonally. Diagonally.
Diagonally. Diagonally. Diagonally. Diagonally. Diagonally. So this problem seems to be a good problem. A matrix diagonal is a diagonal line of cells starting from some cell in either topmost row or leftmost column. And topmost and leftmost in the bottom right direction until reaching the matrix end. For example, matrix diagonal starting from it rains a lot. Matrix 2 0, which is 2 0 here, and then we're met is 6 by 3. What is this? So covariant. There's no explanation actually. So input is 3311 blah blah blah. Output must be 1 1 2 1 2 3 1 2 3 1 2 1. Okay. So let's try to understand the question. So we have 6 here, 6 by 3 matrix. So 6 by 3 matrix, right? Like 1, 2, 3, 4, 5, 6 by 3 matrix. So starting from map 2 0, this one, include the cells 2 0 and then 3 1 and then 4 2, right? Like this. Okay. Wow, so this is very high acceptance rate. So MN 100, okay. So this max of M and N is 100, which means that the number of diagonal element is 100x or less. So so we can sort those elements. we can put those elements into some vector with 100, and if these are smaller, then probably we can resize the vector, right? Resizing may take some time. If we worry about that, then what we can do is we can initialize this vector with some max integer. Here, the max is 100, so we can use like 1000. So we can initialize this vector with 1000. So no, we can just give the number of the element by when we call standard sort. Okay. And then the next tricky thing is that how we can get this element. So one way to do that is from here to here. We don't need to do and then from here to here, right? So from here to here, let's say that the starting point is xy, and then the next starting point is x comma y plus 1, right? And I should buy some pencil. And then the next thing is from here to here, right? So we will we'll get to here. Then after we are doing this, then the next time you can do the x position. So I think I will do two phases. First phase is this part, and the second phase is this part. Okay. So first, let's make a vector. Vector of v, of which size is 100 max, right? So we will sort this and then so initially for each diagonal point, for each diagonal line, what we'll do is copy value into v and then sort v and then store v into diagonal line. This is the way we are gonna do. So for the down direction, what we should do is that we'll have for int. So the x is always 0, right? So let's just use starting x, diagonal starting x is 0, and int diagonal starting y is 1 and 0. So 4, so the next diagonal starting point will be dsy plus plus, right? Until dsy is less than, so here we int max y is v, not v, net that size, and max x mat 0. Can I say 0? Because yeah, the minimum is 1. No, the minimum is 1, so I can say this. And here so here max y, right? Now we have to really focus on this. So copy value into v. So ds, so we will have x, dsx. So 4, so the number is same with max. 4 int kx 0 kx ds max y, then kx plus plus. So one way to solve this is we can define some iterator, diagonal iterator. That way we can use standard library like standard copy, things like that. But here we can do this in very basic level. So what we will do is we're gonna copy kx because x will start from 0, so this will be mat kx, and then y value int ky int ky is starting from, no, we have to declare starting from y, and then ky will also increase, right? So ky in here. So here initially this is 0 0, and then we're going to increase both, so it will be 1 1 and then 2 2, something like that. And then so now we know now this time what we need to do is we're gonna do sort with that begin with that, and then how many plus d max x. So end is exclusive So max x will be right instead of max x minus 1. And then this will sort in ascending order, right? So this is copy map to V, sort V, and then sort V, and then again copy V to map. So now, starting from this one, and then kx is also same. So now, let's copy like this. So this is the down from 0, 0, right? Now, to right from x, y. So now dsx is 1, dsy is 0. Okay. So now, so this time ds here we haven't changed dsx, but now we will change dsx, right? So I'm gonna copy this. Let's carefully concentrate. I'm gonna open my eyes wide. So this time we're gonna move to the y, so yx. So diagonal will be moved to x until, interestingly, until we will, okay, from here dsx, we're gonna start from dsx. Well, this actually, what is this x? So this actually is dsx actually, which is 0, right? Which is 0. You know what? I really want to make sure whether this is not changed. I'm gonna do it like this. And here, int. This is rather long, but let me try this and then let me fix this later. This also return vector. So here in the case we will return matrix. Right? So again from here, and then ky is dxy, okay, dsy. So we're gonna move from kx, dsx, and then we're gonna, okay, seems correct, but this value is now moving from different space, different, you know. So we need some kind of k, and free k equals 0. So let's vk, and then vk, let's add, let's also add vk. So we're gonna to add vk here. So vk will initially vk is 0, but next time it will be 1. So vk's value after one round of loop will be outside of the real value. So this is okay since this is exclusive. So from here, this dxy is constant now, because starting point is always 0. So this is actually 0. So from kx, so we're gonna use the same thing. And then vk is 0, and then ky is actually 0. Let's just use 0. Yeah, okay, I know. Something like this, and then we can do this until vk. Yeah, I think this is it. It's pretty long, but let's first try to think about some test case. So when there is only one element, what will happen? In the case max y is 1, so this will run only once. So we'll copy, but copying these, and then these are not actually necessary. So let's just if v mat size equal 1, and then mat 1 will just return. Okay. And what if, and let's do this case. So here we'll start from 0, and then gonna move from y. And then diagonal starting y will be increased, right? So this is correct. So here diagonal starting point ky, and then kx is actually 0. There's nowhere on which let's do this like this. Snap. Okay, like this. And then kx max x kx. Oh, this is not right, because in this case it will go to here, not to here, right? So and ky max y. So we need this condition too. Oh, is this very important condition. Here and also here. Okay. Yeah, let's not forget this. We'll copy like this to here. And I'm thinking like here we used VK, and let's use this here too, because this is different meaning of variable. So let's do, so we're gonna add VK2. So here not, and maxx is actually not correct, because in this case we're gonna go through only one, not four, right? And then the other way around is VK start from 0, and then VK plus plus. One way of shorten this is that we can use the VK. We know how many VK, you know the number, you know the value of the VK, so we can use different variable from here if you want. So let's remove this. I personally don't like this comma expression, but let's do this with this. And then to yeah, I don't like this. Then from here, so from here, there might be some wrong thing here, because let's check. So dsx, which is 1, dx will increase from here to here. Then we have vk, and then we'll have dsy 0. And what's wrong with you? User undeclared what? Here? Okay. So you're okay. So this is correct. So what's this x? So we're gonna have vk and ky, which is dsy0, and then kx is dxx. Okay, so kx, ky must be smaller than this, and then we're gonna increase this all. Okay, and then sort, and then we're gonna do the same thing again, but in this case we're gonna copy. Okay, 0, same, and same. Okay, yeah, I think it will work. Maybe it's better find some way to shorten the code. So here we have this part and then this part, but basically these two code is same. So Yeah, one thing you can do is that we can make some kind of iterator to define DSX. So from bottom to top and then top to right. So that might be the way. Or can we have some kind of simple way to do this? By the way, the time I spent is 30 minutes. Um, so this is like first thing is like 0, 6, no, 0, 6, 0, 5, 0, 4, 0, 3, 0, 2, 0, 1, and then 0, 0, and then 1, 0, 2, 0, 3, 0. So can you make a simple rule? So one way of doing this is that we will start from 1, 0, and then well, just for fun, just for fun, let's try to make an iterator. So C++ iterator needs three things: begin, and next. So maybe we can gigs for gig with the gigs for gig. So it does not need any specific, not need to extend any specific thing. But we need to know what is the return type. Defining C++ iterator. Yeah. Ooh. So something. What the hell is this language? Okay, const iterator, const iterator. So student list. What is student list? Or a custom iterator in modern C++, integer and data. Struct iterator. Why are tags useful for iterator? Iterator, begin, and it's not an easy work because we have to define this kind of thing. So probably instead of doing this, we can just mimic. class T dynamic variable start. I'm not sure. If I have to this right now, what am I doing? Anyways, it won't take a long time. Diagonal start. So here we'll have DSX, DSY. So initially DSX is 0 and DSY is mat dot size, right? Size -1. And you need to know the max xx. So max x equals mat 0 dot size, right? So here bool move next. So if DSX equals max x if TSX then return false. If TSX equals 0, then it's like this y, then ESX equals 1. And return true if both are 0. If DSY equals 0, this looks fancy but not very readable, so I will just like this. This is 0. Else this y is 0, then the SXY decrease DSY. Okay. And the last thing is that if now else DSX plus plus. So there are only 4 things. Either one is 0, both are not 0. Either one is 1, and both are not 0. So the error case here is when both are not 0. So from here, this is this value is not 0, positive number. So in here, we're gonna decrease this, and then finally this will be here. So we're gonna make dsx equal 0 equal 1. Here dsy is 0. So this else actually means that dsy is 0, dsx is not 0. So actually this means dsy 0. In that case, we're gonna increase the x value, and then we have to return true in this case. So return true, and here we can add weird state if this is this, this, and throw one-time error. Both cannot be positive. Okay, and then this must be private, but yeah. So from here, what we can do is we can make this class diagstart. So diagstart ds, and then context net. So initially we have ds value, right? So from here, dsx and dsx, ds, dsx, and then dsy is dsy. So until move next until and then yes, done, move next is true. Actually, this while this actually this must be do while. So this like this. This is easier to read. Sort now this x, this y, is 0, blah blah blah. I can remove this now. Ah. What's wrong? What is wrong? May TSX, TS5, X. So TSX, this one. I think these are all correct. In that case, the problem could be this one. So let's do the thing which I don't like. TSX, TSY. What? 0, 2. Move next. So this is 4 by 4. This is like this. So 1, 2, 3, 4, 5, 6. So 1, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. One more. So what's wrong? What is okay? So we actually minus 1. So and then so this must be correct. And then 2. Oh. Oh shit. So terrible mistake. Now it should work. Okay. Okay. Although the Yeah, this is because the C out. Let's remove all the C outs. So let's try again. A little bit faster. How could they are this fast? Let's submit some more time. Faster! Oh! Yeah. Okay. Okay, so it took me, for the first try, it took me like 30 minutes. And then after adding some iterator kind of thing, it took me 20 more minutes with some bug. And the reason of the bug, there are two reasons. While I doing that, I forgot to add this line inside. I forgot to move this line inside the do loop. And then the next bug was this. So previously, when it reaches to the end of the X, then try move next must return false, right? So yeah, so this is very, I have to be careful with such thing. When, yeah, I am kind of too much concentrated, too much about, you know, the adding value or subtracting value. So returning false is also very important, but um, I have to be more careful about this. Okay. Okay, guys. See you next time. Bye. Um,